Okay, so we're going to be looking at why protocols are essential for communication between different computers. This is going to be a quick run. Okay, so protocols, oh my gosh, look how thick that pen is. I apologize, pause the video. Protocols allow communication between computers. That is a fact. Without protocols, we won't have rules or standards. These rules and standards look at more or less how data is transmitted, and also some will put how transmitted, but also not just how it's transmitted, how data is received by different computers across a network. Basically, they allow different hardware, operating systems, applications to communicate, I'm going to put comms, effectively. That is the most important. We call this, if we're going to be using geek language, interoperability. So that is probably the most important reason for why we use protocols, but it's not the only reason why we use protocols for communication. Another is to allow data integrity. So by using protocols, we can do error checking. So not only does it provide rules and standards for how data is transmitted and received, so that you've got interoperability across a network for different hardware and different operating systems, it also is for data integrity. Also, not just for data integrity, we've got, and I'm going to do this going this way, security. So you have protocols which ensure that data, when it's sent in terms of transmission, is protected. So the main reason isn't black, but you can also talk about the purple and the pink. Data integrity, data security. I'm going to throw in one more, and that is control flow, to aid the flow of data being sent from one device to another across a network. So it's how data is prioritized. So that is the understanding of why a protocol is essential for communication between different computers. If I just zoom out, there we go. So what we have here is what's called the TCP IP model. My job is to make sure that you guys understand how protocols, and you'll see that these are different protocols. Some of them you might recognize, some of them you might not. How protocols can be viewed as a stack, where each layer, so it's a layer, a layer, a layer, a layer, has different functionality. We're going to be looking at TCP IP model, slash, you can say this is a layers of a stack, all working together. So you need to be comfortable with the terminology of network, internet, transport, and application layers. I'm going to run through with an example of how this all works. Then you're going to know the functionality of each layer in a little bit more detail. But before we begin, TCP IP, there are two different things. TCP is responsible for ensuring that data is reliably sent and received by another computer. Sent by one computer, received by another computer. This will include things like error checking. The TCP is also responsible for breaking up data into packets. And then doing the reverse, reassembling the packets back into data. That is TCP. IP, on the other hand, has its own role. IP is responsible for handling the addressing and routing of packets to the correct destination, to the correct device. So TCP is about reliability, shall I say, error checking, turning data into packets and reassembling. IP is responsible about how we get there. Simple as that. And the role of TCP IP in itself, it is a stack. This stack is basically a set of protocols. These protocols are all about how data is exchanged over the internet. That is the role of TCP IP. So what we're going to be looking at now is simply the 4 layers, how they work, and giving an example. Before we begin, just to let you know that the network layer, which is the bottom layer, could also be called the link layer or data link layer. Interchangeable: network, data link, network. So let's go through it. I'm going to give you the example of sending an email. I'm using Gmail. I'm just going to send an email to somebody, so I'm going to say hi. I'm going to hit the button send. At the moment, I'm in the application layer on my TCP IP model. What will happen is it will attach a protocol to what I'm doing. That protocol will be called SMTP, Simple Mail Transfer Protocol, which we'll talk about at a later stage. SMTP is responsible for handling the sending of emails. So I hit send and it attaches this protocol at the application layer to my data. So it combines them both together. It then is sent down to a next layer. The next layer is called the transport layer. What's going to happen here is it's going to get my email of hi, and it's going to break it down into packets. It's going to add a sequence number, sequence 1 and sequence 2. This will allow it to be reassembled at the next layer. Then we're going to pass it down to the next layer. The next layer is the internet layer. It's going to get these packets, packet 1 and packet 2. It should have like the I in it. It should have the sequence numbers. Actually, I've already got them there. Okay, so it's going to get the packets with the sequence numbers. And what it's going to do next is it's going to assign a source and destination IP address. So it's going to put my IP address on it. And it's going to put in the destination IP address of where I wanted to go to. There we go. Destination IP address, and we've got the sender's IP address. Now what? Well, now that we've got the IP addresses, we're going to route the packets through our network, and it's going to choose the best path for each packet to reach the end goal. In order for this to happen, we need to turn these packets into signals. This is where the link layer comes into it, or the network layer. This is more physical. Network link. But packets are turned into signals, or I'm going to use the word encoded. Those signals could be electric signals, or pulses if you're using fiber optic, so light pulses, wireless, depending on our network. And this is where they're sent over the network. This deals with any type of hardware. So this is us sending the information. So it is sent, and it's going to arrive at its destination. At the receiving side, it will go to the network layer, or the link layer. What happens here is simply, the network interface will detect signals. It will then pass the packets up. So it will now go to the internet layer. At the internet layer, the receiver, so this is the recipient, receiver, the packets now on my network are routed to the correct person's IP address. So you've got to appreciate, if we've got a router and we've got computer 1 and computer 2, it's got to determine which person to pass it to. That's what we're doing now. So when it gets to the network interface, it detects the signals, it passes on the packets, and those packets, which have been, I'm going to add, decoded, are passed up to the internet layer. At the internet layer, it's going to be responsible for recognizing the packets of who we're meant to give them to based on the IP address. So it checks the IP address on the internet layer, which will then hopefully pass it to the right device. It'll then pass it on to the transport layer. At the transport layer, it'll check the sequence numbers and put them in order. Then it'll also do any type of error checking. So it'll do, let's say, a checksum. Uh-oh, there's an error. If there's an error, it'll have to tell the sender that it needs the packets to be sent again. Otherwise, it's passed to the application layer. On the application layer, what's going to happen is going to have a email message which has been at the previous layer fully reassembled and running on the correct app. It would be using a protocol called POP3 for emails to retrieve email. SMTP is for sending, POP3 is for receiving. The email will be downloaded onto my device, and it'll be open in my Google Chrome on my Gmail for me to read. So let's actually have now a look at the different functionalities of each layer. We've got the application layer. The application layer you can sum up as being the connection to programs, apps. It's responsible for identifying communication resources such as protocols. So so such as what protocol to use. If I'm using email, SMTP. If I'm using a web browser, HTTP. It allows the user to interact with apps through network services. I would say that this probably would be your first answer, and you'll support it by talking about identifying what protocol to be using for the application there. We then got the transport layer. You can argue that this is all about smooth communication. It's responsible for reliable transmission of data across networks, maintaining quality, we're talking about how it looks at order, as in ordering the packets. We talk about error checking in terms of functionality as well. We talk about the segmentation of data into packets. And that it uses the protocol TCP. We then have the internet layer. You could argue the internet layer is all about packet transmission. So what does it do? It's responsible for sending packets to destination. Let me just make it a bit bigger. Across networks. Via optimum route / efficient route. We call this, when it works with the IP addresses, etc. We call this in itself kind of like a name, and we call it the logical addressing. Where it maps out IP addresses to devices. We then have the final layer, which is the network layer or data link layer. And this is all about the data transmission. It's all about the physical transmission of data. So that's what it's responsible for. How's data transmitted physically? We talk about encoding the data to a form so it can travel, i.e. for fiber optics it's using light pulses. It does have error detection as well on the lowest level, we can say. It also is responsible for protocols on the hardware layer. So it's responsible for protocols and hardware between devices on even the same network. So if I'm sending it from A to B, but we're in the same building, it'll be responsible for managing the protocols and rules between various devices. So applications, about connections of programs. It's identifying what protocols to use, allows a user to interact with applications through network services. You then got the transport, which is all about smooth comms. It's all about reliable transmission of data across the network, maintaining the quality, putting the packets into order, using sequencing, and it's all about reassembling and the packets when they arrive. It's responsible for the error checking and segmentation, putting data into packets, and the reverse. You then got the internet layer, which is all about the actual sending the packets along that journey, giving them an IP address, mapping the IP address against the devices when it arrives. We then got the physical layer, which is the data link layer, which is all about the network. It's all about what medium are we going to use to send data? Are we going to be using wireless? Are we going to be using physical transmission such as fiber optic cabling or copper cabling? It encodes the data so it can be sent properly. Error checking is carried out, and it does look at protocols between devices which are on the same network as well.